Alright, so chapter 8 was the chapter about exponential functions and logarithms. We know y equals ab to the x is the form of an exponential growth or decay function, and we know that b controls whether it's growth or decay. Which one of these is growth? B bigger than 1 or b smaller than 1? Which one is growth? B bigger than 1 or b smaller than 1? Several of you should be taking notes and being with me here. If I didn't talk to you, then you're taking this test. Nobody knows which one of the out of the remaining people, nobody knows which one of these is growth? That is true. B bigger than 1 is growth and less than 1 is decay. When you look at this question, we can see that the b value is 3. Immediately, we know that this is a growth function. The other part of the equation, the a value, that's the y-intercept of the graph. We know that because the x value is 0. When the x value is 0, we know anything to the 0 power is 1, so that pretty much knocks out this term and leaves the a value. So, when they ask me about the y-intercept in the second part of this question, I look here and I see that it is a 4. I don't care if you write that number as 4 or if you write it as a coordinate 0, 4. They're the same exact thing. Do we have any questions about that first problem? Sure. You want me to slow my roll? Got it? Okay. Question 2. We need to plug these values in. So, 3 squared is 9. 3 to the first is 3. 3 to the 0, anything to the 0 power is 1. And then when we plug in a negative, that causes the base to flip over, so that would be 1/3. And 3 to the negative second would be something to do with 9, but flipped over, 1/9. Now, we all know that exponential growth functions look something like this. So that's a log graph, that's a log graph, so that means that b and d are definitely out. Now, which one of these remaining is the one we want? Well, we're going to take a coordinate, like this one right here, 2, 9, and look for it. So when I come here and I look at 2, it looks like I've got the point 2, 3. Well, that ain't it. But if you look here, you will see the point 2, 9, which tells me that is the correct choice. I didn't need to look for a lot of points. One point did it. As long as I know the basic shape, I can rule out all the bad ones that don't have that shape, and then I can look for one coordinate that will pick out the winner. Any questions about that one? Okay, next question. So, we're starting in 2004, so that means that x equals 0 goes with 2004. It says that we are increasing at a rate of 6%. Now, I remember teaching you that every interest rate starts out at 100%, and it either goes up or down from there. If you go up 6%, what percent are you at? 106%, that's right. And if you need to convert that to, which we do, to a decimal, we move the decimal point 2 places to the left. So we get a B value of 1.06. The 340 is the starting amount. We are starting with 340 billion. So our starting amount, we're not going to write 9 more zeros after that 340. We're going to keep it in billions. And we got our 1.06. Now, they want to know about the year 2019. 2019 is how many years after 2004? 15 years. So now I know exactly what needs to go in my exponent. 15. And maybe I should have done this over here just so that people make the connection. So pull out the handy dandy machine. Make sure you know how to type on your device, whether it's Desmos or a calculator of some sort. We want to make sure we get the same exact result. We'll be over 800 billion. Over 800 billion. And hopefully you got 14.8. And I don't care if you write 814 or 815, one of those two will do. 814.8 or 815, something like that. Just show your work. Where you round to is not the most important thing in the world. Question 4. I see my B value is 0.94, which happens to be smaller than 1. What does that mean? Decay. Thank you very much. That is telling me exponential decay. Oh, the next one is a graph. We know that exponential growth functions typically look like this. And they have a horizontal asymptote at y equals 0. Remember the line that it gets closer and closer and closer and closer to but never touches? Well, what happened with this one? What's that -1 doing there? What is that doing to the graph? Up, down, left, or right? Which way is it moving? It's on the outside of the function. Those of you who are with me, give me a guess. Nobody's willing to give me a guess. Do I bite? Rupert, Ray, Rogers, Robertson, Tung, Watson, what do you got? It's on the outside of the function. If it was affecting the x, then that would be a change left and right. This is either up or down. What do you think? Am I in the same class as some of the people here? minus 1 doing to the graph? It's making it go down 1. Now, isn't that also confirmed by the picture they drew for you? Look here. Here's the line. That's the asymptote, and it looks like it's y equals negative 1. It's been dropped down 1 unit. Okay. Might I remind you? Let's see if I can get this set up quickly. Okay, so here's my picture. What I did in class with you is I said imagine we smash all of the coordinates onto the x-axis. How much of the x-axis would be covered by something? If I continue smashing it onto the x-axis, how much of the x-axis is going to get covered by something? Participation today is killing me. Abbott, Norman, Tom, somebody. How much of that x-axis is covered by something? So, we could say that like this. We could say all reals. We could use the all real number sign, right? The capital R with a double bar. Or we could say negative infinity to infinity. I don't care which way you say it. Okay. Let's try doing this with the y's. Okay, so we're smashing everything onto the y-axis. How much of the y-axis is going to be covered by something? Negative 1, what? And up. Thank you very much. Negative 1 and up. So there's two ways I would accept that answer. Y is greater than negative 1. Or you could say from negative 1 to infinity. Parentheses on both ends. If you're an interval notation fan, I know some of you are not. That's not a big deal. Stick with the inequality notation, but we have something like that. All right. It appears in the graph that it moved down 2. See, the whole thing got shifted down 2 units. So, which one of these says down 2? Well, it's definitely not that one because that's just the basic one. So, which one of the remaining choices says move the graph down 2? A, C, or D? What? Norman, Robertson. D. That is true right there, folks. That says down 2. It's got to be a change on the outside to be up or down. And we know it goes with our common sense. This one is in the exponent and would be to the right 2, so that is definitely not what we were looking for. So next we've got 1/4, which is less than 1. Is that growth or decay? Hopefully we know by now that that is decay. Let's see here. Exponential decay function doesn't look like that. It doesn't look like that. It definitely doesn't look like a growth function. Hey, there's only one that looks like exponential decay. Remember that thing you don't want your money to do? But it's happening every day to your car. Okay, next page. Once again, we have 1/2 is less than 1, so that's decay. And we have a -4 on the outside, which means down 4. So we need to put these two things together to come up with the right picture. Now, I promised you I wouldn't be flipping these things upside down. So, the only one that looks like it's going down, like a decay function, is this one right here, which also got shifted down 4 units because you can see the horizontal asymptote is now down here at y equals -4. Okay, then we had some compound interest questions. We had n values of 1 and 4 and 12 and 365. And the words that we were looking for on those were things like annually, or quarterly, or monthly, or daily. And of course, if you saw one of those words, like this question has, you immediately knew that you were dealing with this equation on the left. And, you knew exactly what the n value was, 1. So when do I use the PERT formula? If you see something like compounded continuously, like we see in the next question down. So we'll be using that equation with that question, not this one. So the amount of money that we have left, well, let's see, here's what I started with. $13,000. It's growing at 8% interest. So, growing at 8%, which is an R value of 0.08. So 1 plus 0.08. Now, you and I both know that dividing by 1 is pretty meaningless. It's not going to do anything to our equation, but I'm going to put it there anyway, just so you know. The n value does occur twice, and we had a time of 8 years. So we need to type this stuff into our calculator to figure out what that number is. Make sure you're using your device and practicing so you know what you're doing. One times 8. Now, you and I both know that 1 times 8 is just 8. So if you just wanted, when you're typing this, and if you just wanted to type an 8 up there, that's fine. If you're at all in doubt, you can literally let the calculator do all the work. Should get over 24,000. $24,600. But if you said $24,062.10, I'd be okay with that. Of course, if it is multiple choice, which I'm not guaranteeing it will be, you could also see the answer sitting right there. So, remember, rounding isn't the biggest of deals for me as long as you do it correctly and you show your work. If you round to the penny and someone rounds to the dime or the dollar, it'll be okay. Any questions on that one? So the next one, we're using the PERT formula. We know that we're starting with $3,000. E is programmed into your calculator, and we're going to raise it. In this case, we've got 5.5%. That's R equals 0.055. So we want 0.055 times the number of years, which is 5 years. So type that in on your calculator. Let's see if we get the same results. Or you could say 3949.6. Take that. If you showed me your work and rounded it to the nearest dollar, I'm not going to argue with you. Just make sure you're showing your work. Question 3. So, looks like the year, see this formula, which demonstrates a 26% growth increase. Wow. A lot of cell phone users going up in that time period. Right, because cell phones were brand new, and so we're going from starting at 1994. So 1994 is x equals 0. Alright, and so we have our formula, y equals 16 times 1.26. We really just need to figure out what we're going to put in here for the exponent. They want to know about the year 2011. 2011 is how many years after 1994? How many years are there between these? Where did you get that? 17 is correct. So now we know what to put in our formula. And Watson, tell me what you end up with. 813.6. That is true. Or if you rounded that to 814 but showed your work, no problems. Any questions on that? Now we start getting into logs. I need to remind you about logarithms. Part of that was graphing. All logarithm functions that have a base of something like 2, 3, 4, 5, 6, 7, they all look the same. Now if you start changing the base to 1/2 and 1/3, yes, it's going to look different, but I'm not going to be doing that to you. But all of the logarithm graphs are going to look very similar to that right there. And that's what we talked about back when we did it. We showed you the graph. We graphed a whole bunch of them on the same Desmos graph, and we showed that they all look basically the same. And what's interesting is they have a vertical asymptote, and nothing crosses that vertical asymptote. They start off with a vertical asymptote at x equals 0. By the time we get to the bottom of the page, you'll see a question where that gets moved. We'll have to figure out which way it gets moved. In fact, let's go down to question 4 and do that. Question 4 got moved. Which way? What is this minus 3 on question 4 telling me? It's on the inside with the x. So we know it's either left or right. Which way? It is to the right. 3 units. Correct. Nicely said. When it's on the inside of the function with the x, we know it goes opposite of our common sense. So this graph, 1, 2, 3, got moved over 3 to the right, which means the basic shape looks like this. But x equals 3 is the vertical asymptote. Okay, so there's my picture. If I smash it all onto the x-axis, how much of the x-axis is covered by some green dot? 3 and above. Okay, so I would accept x is greater than 3. I would also accept parenthesis 3 to infinity. Either one of those choices would be exactly what we need. You're exactly right, 3 and above. Alright, let's go back to question 2. We said that if we want to change this to a different form, like its exponential form, we would have to set it equal to x. And then every time we did this, at least for a while at the beginning, I drew boxes. And then we had to figure out what went where. So of course, we know the base is going to go here. We know the exponent is going to go there. And that leaves one box left, which will be called the argument. Your choices are 8, 64, or x, 8, 64, or x. Which one of those is the base? Norman, what do you think? 8, 64, or x? Eight is the correct base. Nicely said. Yep, that is your base. So now we have two choices for exponent. It's either 64 or x. What are we thinking? Tongue or Abbott? Which one is the exponent? 64 or x? It is x. Thank you very much. Remember, I kept writing things down like logarithm means exponent. Logarithm means exponent, so log means exponent, so x is, and that leaves one box left, which is 64. So to continue this question, we would say things like, okay, we know the left side is 8 to the x, but how could I rewrite 64 as a power of 8? Is it 8 to the first? Is it 8 to the second? 8 to the third? 8 to the fourth? 8 to the fifth? Hopefully you would say 8 squared. And then I said things like, okay, if the left side equals the right side and the bases are the same, what do we know about these two exponents? What do we know about them? They have to be equal. And so we would set up a small equation with just the exponents. And sometimes it was already solved. Sometimes we had to do a little bit of work. Question 3 is a graphing question. We know what exponential growth functions look like, and 5 to the x, 5 is greater than 1. So I definitely know that this is growth. And then they say, well, what about y equals log base 5 of x? We know what a logarithm function looks like. I know that they're not labeled A, B, C, D, but which one of those has a similar looking picture to the one with the blue and the red on it? What are you thinking, Rupert and Rogers? It is this second one, that's true. Yep, that's the one that has a similar looking shape. Okay, next side. How does the graph of the following function compare with? Okay, so we can see that this is on the outside of the function, that plus 1. What is that plus 1 telling us? It's on the outside of the function, so it's definitely not left or right. What is it? Hopefully you know that that's up 1. So we need a logarithm function. We know all the logs look something like this. Sorry, a little bit off screen. And it's been moved up 1. Well, that doesn't look like a logarithm. That doesn't look like a logarithm. Now some of these might be upside down logs, but I told you I would never do an upside down log. That's the only one that looks like a regular logarithm graph that got shifted up 1 unit. And yes, the blanks would say something like shifted 1 unit up or up 1 unit. I don't care. Rewrite that into its logarithm form. Okay, so we're going the opposite direction now. We've got 3 boxes to fill in. We know that the base will go down here. We know the exponent will go over here. So, Ray, which one do you think is the base? 49, 7, or 2? 7 is correct. Thank you very much. So, Norman, your job got easier. Your choices are 2 and 49 because Ray already took out the 7. What do you think the exponent is, 2 or 49? 2, that is correct. And that leaves us with 49 left, and that's the end of that question. They just asked me to write it in log form. That's all they asked me to do, nothing else. See if we can get 2 more done here. So using our log properties, I just want you to write as a single log. That's really the goal here. If you could write this as a single log, I'll be very happy. It looks like I'm going to start with property 3, King Julian's property. What did King Julian tell us? What did he tell us to do with this coefficient? Move it, that's right. Told us to make it an exponent. And so that would literally say log base 3 of 81 minus log base 3 of 3 squared. Do we know what 3 squared is? 9. So we have log base 3 of 81 minus log base 3 of 9. So that completes King Julian's property 3. And now we've got to use property number 2. Now, property number 2 talked about subtraction. What does subtraction go with? Subtraction goes with which other operation? Think about when you're subtracting exponents. Nope, it is not addition. That would be property number 1, which we will use that on the next question, so I'll write that down. Property number 1, that's multiplication and addition. They go together. So, if it's not multiplication and addition, what's the only one left? Division. So, we would like to take the 81 and the 9 and create a single logarithm with those two things. But do we know 81 over 9? It is 9. So the final answer I'm looking for is log base 3 of 9. Obviously showing the work. Now I'm going to tell you that's a full credit answer. There is a way you could go for extra credit on this question if you wanted to. Maybe I should write that over here. If you set this equal to x, you could rewrite it into its other form, 3 to the x equals 9. Then you could say, well, 9 is 3 squared, so what is x? Hopefully you notice that it is 2. So if you did this, I would give you extra credit on that question. But if you just stop with log base 3 of 9, I'll be good with that. And since we already did mention the property number 1, this should be really easy. Property number 1 is multiplication and addition. You see multiplication, so which one of these goes with it? Come on. Which one? D, thank you very much. That goes with this. And we'll get the rest of these tomorrow.